Unit 6, Lesson 6, Applications Part 1. So applications in this unit involve giving you guys an equation, and then you have to answer a bunch of questions by applying the equation. In the first example, we are told that this equation models the height of a Ferris wheel. Okay, so a Ferris wheel goes around and around, so it's cyclical. Obviously, it's going to be modeled by a sinusoidal function, so either sine or cosine. So let's start with part A, and keep in mind that h represents the height of a certain seat after a certain amount of time. So let's say you have a seat right here. As time goes on, what height is the seat at? Okay, so there's your background information. Let's now answer the questions. Part A, determine the height of the seat after 5 seconds. So we want to figure out what h at 5 is. So we'll plug in 5 for t and solve. Okay, so I'm going to simplify inside of the brackets first. And then I'm going to solve this completely in one step, so just make sure that you have brackets around your cos 48. And you should get 17.7 meters. So that means that the height of the seat after 5 seconds is 17.7 meters. Okay, part B, how long does it take to complete one revolution of the wheel? So basically they're asking for the period. Okay, how long does it take to complete one full cycle? So, to answer this question, we need to look at the equation, right? Because we know that the period is equal to 360 divided by the k value. Okay, that's a very important equation that you memorize. Okay, there is a relationship between the period and the k value. Okay, if you know the k value, you can find the period, and if you know the period, you can find the k value. So the period here is equal to 360 divided by 12, because that's our k value. So our period is 30 seconds. So it takes 30 seconds to do one full revolution. Okay, part C. What is the amplitude of the function? What does that mean in this scenario? So let's figure out the amplitude first. Okay, well we know that the amplitude is equal to the a value in an equation. So our amplitude must be 10. Okay, but now we have to apply that to the scenario. So an amplitude of 10, what does that mean in terms of the Ferris wheel? Okay, and to figure that out, I want you to picture this. Here's the axle that the Ferris wheel is spinning around. Okay, it's kind of the midway point. So that can be thought of as your Q value. So, knowing that the maximum point that a seat is going to reach would be up here, and the minimum point that a seat is going to reach is down here, wouldn't the amplitude then be the distance between one of those max or min points and the axle in between? So there's your amplitude. Or you could say that this is your amplitude, right? So what does that mean in terms of the Ferris wheel? Well, we could say that the amplitude is equal to the radius of the Ferris wheel. Okay, part D, what is the equation of the axis of the curve, and what does it mean in this scenario? Okay, well, we already know that the axis of the curve is going to be the distance that is halfway between the max and the min. Or it is equal to the axis of the curve, which we know is our Q value. Right? So to answer the question, what is the equation of the axis of the curve? Let's look at our equation and let's use the Q value. So the equation of the axis of the curve is y is equal to 11. And now we need to apply that to the scenario. Okay? All it means in terms of the Ferris wheel is that's the height or where the axle is. Right? So the axis of the curve is equal to where the axle is, or the rotating point is, on that Ferris wheel. Okay, part E, let's sketch the graph. Okay, so because it says sketch the graph, it doesn't need to be anything super accurate, but we still need to make sure that our key points are located on this sketch. Okay, so obviously my x-axis is time and my y-axis is height. Okay, so some things that we know. Because our graph is modeling the height of a seat over time, we know that that seat is going to start at a height of 0. Okay, because to get onto the seat, it needs to be at the ground level. So we know our first point is right there, okay? We also know that our period is 30 seconds. So after 30 seconds, it's going to return back to the starting point. So we know at 30 seconds, there's also a point at 0. We know that our axis of the curve happens at y equals 11 because of our q value being 11. We know that our maximum is going to happen halfway in between our two zeros. So we know that our maximum is going to be generated by the x value of 15. Okay, and then to figure out what that maximum value is, we can take our amplitude and add it to our axis of the curve. So our amplitude is 10. So that means our maximum is located 10 meters above our axis of the curve. So if we add 10 to 11, we get 21. So we know our maximum, or our optimal value, is at 21. Okay, and finally, some other points we know that we can add to make our graph more accurate is the point we found in part A. We know that after 5 seconds, the height is 17.7. So let's plot that in. Okay, and then if you really understand how to draw these cosine graphs, you know that they're symmetrical. So if there's a point at 5 and 17 and 7, there's also going to be a point at 25 and 17 and 7. Okay, now we're going to connect the dots. Okay, and obviously it's not absolutely perfect because I didn't use an actual grid, but now we have a good sense of what our function looks like when it's graphed. Okay, it's a cosine function that has been reflected on the x-axis. Okay, part F. When is the height of the seat 5 meters in the first minute? So this question is saying we know the height is 5 meters. Find the time that this happens at. Okay, so we're going to take our equation. Okay, we know the height is 5, so I'm going to replace h at t with 5. And then I'm going to solve for t. Okay, so I'm going to start by subtracting 11 from both sides, and then divide both sides by 10. Then if I expand those brackets, I get 12t minus 12. Okay, so we kind of get into a standstill here. And I want you guys to pause the video and go back and look at Unit 4, Lesson 8, Solving Trig Equations, Part 3. Okay, so that's when you're solving trig equations, when it's not just cos theta equals a half. It's cos 2 theta equals a half. Okay, I want you to remind yourself what we did to solve those types of questions because we're going to have to do that here. So take a second, pause the video, go back and relearn Unit 4, Lesson 8. Refresh your mind. Okay, so the first thing we want to do is we want to let alpha equal 12t minus 12 in order to simplify our expression. So now we have an expression that's negative 3 over 5 is equal to cos alpha. Okay, then we're going to solve for our values of alpha, and then at the very end, we're going to readjust our question so that we can actually find our true values of t. Alright, so if you remember from Unit 4, Lesson 8, we need to find the related acute angle. So we're going to take the positive value of the ratio and solve. Okay, so I just switched it with beta to officially declare that I'm finding the related acute angle. Okay, so you're going to take the inverse of cosine. And you're going to get 53 degrees for your related acute angle. Okay, so we know that cosine is negative in quadrant 2 and quadrant 3. So let's go ahead and draw our terminal arms with the related acute angle of 53 in quadrant 2 and 3. Okay, now we can use this to find our values of alpha. So alpha 1 is going to be 180 degrees minus 53 degrees, which is 127 degrees. Alpha 2 is going to be 180 plus 53 degrees. So it's going to be 233 degrees. Okay, are there any more values of alpha? And to determine that, we need to look at our domain. So our original domain was time had to be between 0 and 60 seconds, because if you look in part F, it says when is the seat 5 meters high in the first minute. So that declares our domain is within the minute. Okay, so our original domain was t had to be greater than 0 but less than 60. But remember from Unit 4, Lesson 8, we have to adjust our domain because we swapped out 12t minus 12 with alpha. So we need to do the same in our domain. So our new domain is actually going to be this. Let's plug each end of the domain into 12t minus 12. And I get negative 12 as our lower end of the domain and 708 as our higher end of the domain. So I can keep figuring out values of alpha as long as I don't get values that are less than negative 12 or higher than 708 degrees. So let's take alpha 1 and add 360 to it and see if there's another value of alpha that's less than 708 degrees. I'm also going to take alpha 2 and add 360 and see if there's a fourth value of alpha. Okay, we do get a value there because that's still less than 708. We get 2 extra values of alpha, and that's it. Because if we keep going and adding 360, we know it's going to be over 708. We also know that we can't subtract 360 because we're going to get values that are less than negative 12. So we can conclude that we have 4 values of alpha. So now, if you remember in Unit 4, Lesson 8, the next thing we have to do is we have to convert them back to values of t. So let's take each of these 4 values of alpha, set them equal to 12t minus 12, and find our values of t. Okay, so therefore, this seat is 5 meters high after 11.6 seconds, after 20.4 seconds, 41.6 seconds, and after 50.4 seconds. Okay, and finally, part G. When does the seat reach a maximum and minimum height? Okay, well for that we can look at our graph. We know that the graph reaches a maximum height after 15 seconds and a minimum height after 0 and 30 seconds. Okay, this question is complete. Okay, example 2. A loose nail is attached to one of the paddles on a water wheel. At its highest point, the nail sits 10.5 feet above the surface of the water. After 12 seconds, the nail reaches its lowest point, which is 1.5 feet below the water. Okay, so we can kind of use the water level as a reference point, and even more specifically, we can say that the water level is 0. Anything below the water level will be a negative value. Anything above the water level will be a positive value. Okay, so determine the equation that can model the height in feet of the nail, t seconds at its highest point. So let's start figuring out our key values, A, P, Q, and K. So the only information we are given is we know that the maximum value happens at 0 and 10.5. And we know our minimum value happens at 12 and negative 1.5. Okay, so we have to use that information to find A, Q, K, and P. So the first thing we can find is our Q value. Our Q value is going to be halfway between our maximum and our minimum, which is going to be 4.5. Okay, our A value, or amplitude, is going to be the distance between either the max and minimum and our Q value. So if I take my maximum and I subtract that Q value, that'll get me my amplitude, which is 6. Okay, and our amplitude is the same as the A value in the equation. In terms of finding K, so we need our period, because remember there's a relationship between the K value and the period. So to find our period, we know that half the period occurs between the maximum and the minimum value. Okay, so half of our period is going to be the time between 0 and 12. So we know half our period is 12 seconds. So that means our full period is going to be 12 times 2. Okay, so now that we know our period, we can find our K value. So our K value is equal to 360 divided by our period. So our K value is 15. And finally, we know there's no phase shift because we're starting at our maximum, right? At 0 seconds, we're already at our maximum. So if we use the cosine function, we know that there's no phase shift because cosine starts at its maximum. All right, so using all this information, and we've determined we're going to use cosine because it starts at its maximum. Here's our function. Okay, part B. When will the paddle reach a height of 7 feet? So we'll plug in 7 and we'll solve for time. I'm going to subtract 4.5 from both sides and then divide by 6. And I'm going to get 0.42 is equal to cos of 15t. Now we're going to let alpha equal 15t. So we have 0.42 equals cos alpha. Now let's find our related acute angle. So our related acute angle is going to be equal to 65 degrees. Okay, so we know that cosine is positive in quadrant 1 and 4. So let's draw terminal arms in quadrant 1 and 4, and those terminal arms have to have a related acute angle of 65 degrees. Okay, so now we can use that to find our values of alpha. So the first value of alpha is the same as the related acute angle. So alpha 1 is 65 degrees. Our second value of alpha is going to be 360 degrees minus 65 degrees. So alpha 2 is going to be equal to 295. Okay, because our question does not give us any indication of what the domain is, like it did in our last question, we're just going to solve for these two values. And then we could, if we wanted to find more occurrences, we could go ahead and apply our period to determine that. So let's now convert these values of alpha back into values of t. So alpha 1 is equal to 65 degrees. So we will set 65 degrees equal to 15t, and we will get our first t value at 4.33 seconds. Our second value of alpha was 295 degrees. So we'll set 295 equal to 15t. And we get t2 is equal to 19.67 seconds. So that means that the paddle will reach a height of 7 feet after 4.33 seconds and after 19.67 seconds. Okay, the last thing we need to do is construct a graph of our function. Okay, so let's put on our points that we know. So we know that we have a maximum right away at 0 and 10.5, okay? We know that our minimum occurs at 12 seconds, and that minimum is negative 1.5. Okay, we know that our period is 24 seconds, so after 24 seconds, the height is going to be back at where it started. So we're going to have another point at 10.5. Finally, from part B of the question, we learned that the height is 7 feet after both 7.33 and 19.67 seconds. So we know we're going to have 2 other points that we can plot on that graph. Okay, and the last you should put on that graph is the axis of the curve, right? That occurs at 4.5. Okay, our final example. A group of friends is tracking a friend, Nick, who is riding a Ferris wheel. They know that Nick reaches his maximum height at 11 meters after 10 seconds, and he reaches his minimum height of 1 meter after 55 seconds. Determine an equation that can be used to determine his height after 78 seconds. So in order to determine our equation, we need to come up with our A, Q, K, and P values. Okay, so the only thing that we are given is the maximum point, which occurs at 10 seconds, and he gets to 11 meters. And we know that the minimum occurs after 55 seconds. He gets to a height of 1 meter. Okay, so we can find our Q value. So Q is going to be the distance that's halfway between the max and the min. So 11 plus 1 divided by 2, which equals 6. So our Q value is 6. We know our A value is the same as the amplitude, which is the distance between the max and the axis of the curve, or the min and the axis of the curve. So A is going to be, if we take our maximum and subtract the Q value, we get our amplitude, or A value, so 5. We know that half the period occurs between the maximum and the minimum. Okay, so 55 minus 10 is going to be half our period. So our full period is going to be 45 times 2, which is 90. Now that we know our period, we can find our K value because we know there's a relationship between the K value and the period, right? 360 divided by the period is our K value. So our K value is 4. And finally, we need to find our P value. Okay, so we know that cosine starts at its maximum. So our maximum occurs at 10 and 11. So if we pick the cycle of cos that starts at 10 and 11, we know that it's going to have a phase shift to the right 10. So let's do that. Okay, so from all this, we can say that f at t is equal to 5 cos 4 t minus 10 plus 6. Okay, now we can use this equation to figure out what the height is after 78 seconds. So f at 78 is equal to, just plug in 78 for t, and now let's solve this. So therefore, Nick will be 6.17 meters high after 78 seconds.